2.5 million years ago, in the heart of the Andromeda galaxy, a star died. Not quietly, not gracefully, with a roar that shook the fabric of space. Trillions of tons of plasma erupted into the void. Planets vaporized, nebulae ignited. A pulse of radiation raced outward at the speed of light. A silent scream across the cosmos. It took 2 million years to reach Earth. By then, the explosion was long over. The stars had faded. The dust had settled. But we did not know. We did not see. In 1885, astronomers on Earth saw a sudden flare in the constellation Andromeda, brighter than any star in our sky. They called it S Andromeda. They thought it was a nova inside our own galaxy. They were wrong. It was a supernova, the death cry of a giant star in another universe of stars. Andromeda was not a nebula. It was a galaxy, like ours, larger, older, more violent. And now, it is coming for us. Not with weapons, not with fleets, but with gravity, with time, with the slow, inevitable pull of cosmic fate. This is not science fiction. This is physics. And in less than 5 billion years, it will end everything we know. In 1885, the night sky changed. A single point of light flared in the region once known as the Andromeda Nebula. For 6 months, it burned brighter than all other stars combined. Then it vanished. No trace, no remnant, no explanation. At the time, astronomers believed the Milky Way was the entire universe. Everything beyond was just gas, clouds of luminous mist. But this flare defied logic. It was too bright, too distant, too permanent. It could not be a star in our galaxy. Yet no telescope could measure its distance. The instruments were crude. The math was incomplete. For decades, S Andromeda remained an anomaly, a ghost in the data. Then came Edwin Hubble. In the 1920s, he used the Hooker telescope at Mount Wilson to observe Cepheid variable stars in the Andromeda Nebula. He measured their pulsation periods. He calculated their distances. The result? Over 2 million light years away. Andromeda was not a cloud. It was a galaxy, a spiral of 1 trillion stars, a mirror of our own. And S Andromeda? It was the first supernova ever observed outside the Milky Way. A beacon from another world. A warning. We didn't understand it then, but now we do. Andromeda is not just big. It is structured, elegant, violent. Its spiral arms stretch 150,000 light years across, wider than the Milky Way. Its mass, between 800 billion and 1.5 trillion solar masses, nearly identical to ours. But its composition is different. Fewer dark matter halos, more red dwarfs, fewer massive stars in the outer regions. Its central bulge is dense, packed with millions of ancient stars. Light from this core is so intense, it drowns out individual suns. You cannot see them, only the glow. And at the very center, something stranger. A double nucleus. 2 stellar clusters orbiting each other. One large, bright, 7 light years wide. The other small, dim, just 1.3 light years across. Hidden within it, a supermassive black hole, 50 million times heavier than the Sun. Why 2 nuclei? Was it once 2 galaxies that merged? Or is it one, split by a veil of dust? We don't know. Spectral analysis shows motion, rotation, but no clear answer. The structure defies models. It does not fit, and that is why it fascinates. Because the universe doesn't care if our theories are clean. It only cares if they are right. Deep in the core of Andromeda, hidden behind the glare of 1 billion stars, lies a quiet killer. An object invisible to optical telescopes. But in X-rays, it blazes brighter than anything else in the galaxy. M31 X-1, a binary system, 2 stars locked in a deadly dance. One is a neutron star, small, dense, just 20 kilometers across, spinning 3 times per second. Its magnetic field is 1 trillion times stronger than Earth's. The other is a red giant, bloated, old, dying. Their orbits? For hours. Every 4 hours, the red giant passes in front of the neutron star. The X-ray light vanishes, then returns. Each eclipse tells us more. The red giant is losing mass. Its outer layers are being torn off, pulled into a swirling disk around the neutron star. The material heats to millions of degrees, glows in X-rays. In tens of millions of years, the red giant will be gone, swallowed, crushed, turned into a ring of fire. The neutron star will grow heavier until it collapses under its own weight, becomes a black hole, and in that moment, the last light of M31 X-1 will fade, but not before it has consumed its partner. This is not rare. It is routine. In every galaxy, stars die like this. Slowly, quietly, without fanfare. But here, we can watch it happen. From 2.5 million light years away, Andromeda has a bar, a straight line of stars cutting through its center. 18,000 light years long, 6,000 wide, almost invisible from Earth because we view it edge-on. It is not decorative. It is functional. Gravity pulls gas toward the bar. The bar funnels it inward, feeds the central black hole, fuels star formation. 3% of Andromeda's total mass, concentrated in this single structure. It is the engine of the galaxy. Without the bar, the spiral arms would unravel. The gas would drift. The stars would form randomly, but the bar channels chaos into order. It is the reason Andromeda looks like a wheel, not a smear. And yet, even the structure is changing. Observations show it is slowly rotating, twisting, warping, as if pulled by unseen forces. Perhaps by dark matter, perhaps by a passing dwarf galaxy. We do not know, but we know this. The bar is older than the arms, older than most of the stars. It is the skeleton upon which the galaxy was built. The spiral arms of Andromeda are not smooth. They are jagged, broken, wide, 13,000 light years between some arms, twice the width of those in the Milky Way. Within them, vast clouds of gas and dust, molecular hydrogen, carbon monoxide, silicate grains. These clouds collapse under gravity, form new stars, open clusters, associations. NGC 206, the largest star association in Andromeda, spans 200 light years, contains 300 bright stars, total mass 200,000 suns. It glows so brightly, amateur telescopes can see it alongside the galaxy's core. It formed from the merger of 2 gas clouds, one 10 million years old, one 50 million. Their collision triggered a wave of starbirth. Some stars here will live for billions of years. Others explode in supernovae within a million. This is how galaxies grow, not by magic, by destruction, by rebirth, by fire. The arms contain 56% of Andromeda's stellar mass. They are where life might begin, where planets form, where worlds are born, and where, someday, someone might look back at us. Among the brightest stars in Andromeda is Andromeda, a blue giant, hotter than any star in our sky. Surface temperature, 20,000 Kelvin. Luminosity, 700,000 times the sun radius, 55 times larger than the sun. So large, its outer atmosphere reaches past Mercury's orbit. It loses 2 quadrillion tons of mass every second. A stellar wind faster than 100 kilometers per second. It sheds 10 Earth masses every year. But for a star this massive, it is nothing. It still holds 50 to 120 solar masses. It is young, only 2 million years old, but already near death. Blue giants burn fast. live fast, die young. In less than 1,000,000 years, AE Andromeda will run out of fuel. Its core will collapse. Its outer layers will explode. It will become a supernova, a flash brighter than 1,000,000,000 suns, a burst of gamma rays, a shockwave that will sterilize nearby systems. But here's the twist. It may not wait. Blue giants like E Andromeda are unstable. They erupt without warning. Superluminous flares, supernova imposters. In 2008, a similar star in another galaxy flared up, becoming 10 million times brighter than the sun for weeks. Then faded. No explosion, no death, just a tantrum. AE Andromeda could do the same tomorrow, or in 50,000 years. We cannot predict. We can only watch and wait, hoping it does not happen while we're looking. Look at Andromeda's stars, and you see its history. In the center, the oldest, 11 to 13 billion years old, formed when the universe was young, when heavy elements were rare, when galaxies were small. Around them, younger stars, 3 to 4 billion years old, formed during a period of intense starbirth. In the spiral arms, babies, stars born just a few million years ago, younger than the dinosaurs, newborns, still wrapped in gas, still glowing with infrared heat. The distribution tells a story. Andromeda began as a small elliptical blob. Slowly, gas fell inward, formed a disk, then spiral arms, then bars, then satellites. Each layer, a chapter, each cluster, a sentence. We are reading the galaxy's autobiography, written in light. Is there life in Andromeda? We don't know, but we can guess. The center? Too hot, too crowded, too much radiation, too many supernovae, too many black holes, too many gravitational tides. Impossible. The outer rim? Too little metal, too few heavy elements. No rocky planets, no water, no chemistry for life. But the middle? The sweet spot, 30 to 50,000 light years from the center, where stars are spaced far enough apart, where radiation is low, where metals are abundant, where planets can form, stable orbits, long-lived stars. Here, Mega ML7, a dim red dwarf, mass half the sun's, temperature 3,700 Kelvin. In 1999, astronomers detected microlensing, a tiny, temporary brightening caused by a planet passing in front of it. The signal was faint, but real. The companion, Mega ML7b, likely a gas giant, 6 times Jupiter's mass. Orbital period? Unknown. Distance? Unknown, but exists. If confirmed, it will be the first exoplanet ever discovered outside the Milky Way. And if there is one, there are thousands. Million. Rocky worlds, oceans, atmospheres, ice caps, forest cities, watchers, looking back, wondering who we are. We may never know, but the possibility changes everything. Andromeda has eaten more than 100 galaxies. Most vanished without a trace, dissolved into streams of stars, but some left scars. M32, a compact elliptical galaxy, is one of them. Only 17,000 light years from Andromeda's disk. Diameter, 8,000 light years. Mass, 1 billion solar masses. Surprisingly large for its size. Why? Because it is not whole. It is a remnant. About 800 million years ago, a larger galaxy slammed into Andromeda's spiral arm. A cosmic bullet. The impact tore open the disk, created a gap, flung stars into space. M32 lost 99% of its stars. What remains? Its core, its black hole, 2.5 million solar masses. The rest? Gone, scattered, forgotten. Now, M32 orbits Andromeda like a satellite, a broken tooth in a jaw. But it is not alone. There are 30 satellite galaxies. M110 bright, large, a dwarf elliptical, dozens of smaller ones, dwarf spheroidals, clinging to Andromeda like moths to a flame. Together, they form the Andromeda subgroup, part of the local group. And the local group is falling toward a common center, toward each other. The Milky Way and Andromeda are moving toward each other. 300 kilometers per second. That's 1.08 million kilometers per hour. Faster than any human-made object. In 4.5 billion years, they will collide. Not like cars, not like asteroids, like ghosts. Stars rarely crash, but gravity will weave them together. The disks will warp, the arms will tangle, gas clouds will ignite. Billions of new stars will form, black holes will merge, radiation will flood space. Our solar system will be thrown into a new orbit, possibly ejected into intergalactic space, or swallowed into the new galactic core. But by then, the sun will have died, already swollen into a red giant, already scorched Earth, already turned oceans to steam, already erased all life. We won't be here to witness it. But if we survived, if we colonized Mars, Europa, Titan, Proxima Centauri, we will see the skies change. Two galaxies merging, two spirals twisting into one. A new shape, elliptical, red, old, dead, a graveyard of stars, a monument to time. We will call them Andromeda, or Andromeda Milky Way, or simply the end. And we will wonder, was it inevitable? Was it always meant to be? Or could we have escaped? Could we have moved faster? Could we have built ships to leave the local group? To fly beyond gravity's grasp? We do not know, but we know this. Galaxies do not survive forever. Neither do stars, nor planets, nor civilizations. The universe does not preserve. It transforms. It consumes. It forgets. And we are part of that process. Andromeda's visible stars, only 10% of its mass. The rest? Dark matter. Invisible. Undetectable. Except by gravity. It forms a halo, spherical, extending far beyond the spiral arms. 10 times wider than the visible galaxy, holding it together, preventing the stars from flying apart. Without dark matter, Andromeda would disintegrate. Its rotation would slow. Its arms would unwind. Its stars would drift. We do not know what dark matter is. We only know it exists. Because without it, galaxies like Andromeda could not form, could not survive, could not hold their shape. We are made of atoms, but the galaxy is made of shadow. And we are the reflection of that shadow, the light that remembers the dark. We think of Andromeda as a neighbor, a beautiful object in the night sky, a photo in a textbook, a target for telescopes. But it is not. It is a mirror. It shows us what we will become. We are not special. We are not unique. We are not safe. We are one of trillions of galaxies, one of trillions of stars, one of trillions of planets, one of trillions of moments. Andromeda is not coming to destroy us. It is coming to remind us that everything ends, that everything changes, that even the strongest structures, galaxies, stars, civilizations, are temporary. We are not the center. We are not the purpose. We are the echo, the whisper, the flicker of consciousness in a universe that does not care. And yet, we ask questions. We build telescopes. We send probes. We dream of colonies. We write stories. We look up and we say, what happens next? That is our greatest strength and our greatest tragedy, because we know we will vanish, but we refuse to stop asking. Andromeda will swallow our galaxy. Time will erase our name. Stars will die. Black holes will evaporate. The universe will cool. And then silence. But for now, we are here, looking, wondering, alive. And that is enough. The Andromeda Galaxy is not a threat. It is a teacher. It teaches us that galaxies are born in fire, live in chaos, die in Längse, that stars are born in clouds, burn in fury, dissolve into dust, that life is rare, fragile, brief, and that even the most powerful structures, even the most brilliant civilizations, are only temporary. We are not destined to survive. We are destined to witness, to feel awe, to remember, to ask, what? Even when there is no answer. Even when the answer is, because the universe does not owe us anything. So when you look up tonight and see the faint smudge of Andromeda, remember this. You're not looking at a galaxy. You're looking at your future. And you're still here, still alive, still wondering. And that is the most miraculous thing of all. We hope this journey ignited your curiosity. Stay with us as we explore the cosmic tragedies that shaped our existence, the silent giants that loom in the dark, and the fragile miracle of awareness in a universe that refuses to remember. Subscribe and join us for the next discovery.